All right. As I said, we were hoping to do a joint presentation here today. We're going to talk about soil health and water quality. Dr. Osterholz presented some of this at the recent Conservation Tillage Conference in Ada. And starting off with soil health, I think pretty much everyone who is on this call understands what soil health means, what the context is. Just wanted to start with that slide here that really the context here is these principles of soil health where you're minimizing the disturbance of the soil, maximizing the biodiversity, uh, maximizing soil cover, and maximizing the living root system. Um, some of the practices that may help you achieve those principles are cover crop, minimal tillage or no-till, diverse crop rotation, manure application. Together, what they do is bring in a lot of biomass into the systems and minimize that soil disturbance. So we have a lot of research that focuses on how these particular practices directly affect soil quality or soil health. We're taking one step further and um, also looking at how the improvement might relate to water quality. It's always good to start with how the soil health itself is affected, and we're just gonna spend a little bit of a time here on how the soil health indicators are affected in by these practices. Uh, so really what this is a majority of this work is Dr. Will Osterholz who did this work, but many of you have seen this slide being presented in different settings. The USDA-ARS Soil Drainage Research Unit here at Ohio State that is led by Dr. Kevin King. Will is also part of that team. So they have an extensive network of paired field sites across the state. Majority of them are in Northwest Ohio. Each little dot here is a paired field site. So each dot would have 2 or 3 agricultural fields that are being monitored for mainly for water quality at the edge of the field. As part of that, what they're monitoring is the tile drainage coming out of the that field and surface runoff. So we're monitoring the flow, the discharge from these surface and subsurface pathways, as well as we're able to collect some automated samples, water samples, which we then analyze for water quality, mainly nitrogen and phosphorus. Just a quick overview of how this network looks like. There is about 40 agricultural fields that are part of this network. Some of the earliest fields were started, the monitoring started about 10 years ago. Something to understand, the water budget for our agricultural landscapes, especially Northwest Ohio, you all know that it's heavily subsurface drained landscape, and on average, a majority of water that is being lost from that field finds its way out through a tile system, a tile drainage system, or a tile drainage outlet. About 80% of that water is going to be lost from the tile drainage system. If you look at the numbers, about 40 inches of precipitation, what that we get in a year, about half of that just goes back into the atmosphere as evapotranspiration. Whatever is remaining, about 10 to 12 inches is what you are going to see at the tile outlet. Another 2 to 4 inches is what you'll see in terms of the surface runoff loss. But it more importantly, that tile drainage loss also accounts for about 70% of the phosphorus losses and more than 80% of the nitrogen losses from our agricultural fields. So now you can see how important it is to really focus on this subsurface drainage pathway. A majority of those soils are silt loam to clay soils. Typical corn soybean rotation is and our corn soybean and wheat rotation is very common. But then the network of those 4D fields also includes practices like no-till, fertilizer, manure management, cover crops, crop rotation, and drainage water management. So it's a very good representative set of fields that is part of this network. So what the soil group has done here with the ARS is really focus on the last 5 years of management and then how that relates to soil health indicators. And by management, the definition here is what kind of soil cover was there in the new non-growing season, the tillage intensity, manure application, rotation and diversity, and then general soil texture. These are some of the soil properties or soil health indicators that we're going to talk about today. Organic matter, POC is really active carbon in the soil. So typically when you're doing your soil test, if you get the soil organic matter, what they do is they take a small sample of small sample of soil and burn that in the lab, and then the difference in the weight is the total organic matter. So really, the total organic matter, the active organic matter is only the active portion of that. That plays a major role in the day-to-day processes. Soil proteins is another good indicator of soil health, and then 24-hour CO2 burst, the carbon dioxide burst, is another one, and aggregate stability, which is a more of a soil physical property that we're going to look at. So I guess I should have stayed on this slide. There is some general and chemical and biological. So there is a good representation of chemical, physical, and biological indicators here in the mix. So here is the results from multiple linear regression models that Will has been able to run. I'm going to take a pause and check with my hosts if you had any success reaching out to Will.
We sent everything to him again via email.
Okay. All right. So you can see when you run a regression model here, organic matter and so organic matter as a function of manure, cover, and texture. This model is able to explain about 29% of the variability. So essentially, if you look at this, the active carbon, that tends to be a really good representation of all of these factors combined together. It explains about 53% of the variability in the active carbon itself. So the summary of all of the analysis that was behind this is manure had the greatest positive impact on the soil health indicators. As you can see, every place that you see the green, that's where those factors are playing a major role. So manure application in that data set actually relates really well with the soil health indicators across the physical, chemical, and biological indicators. Tillage intensity had kind of a mixed effect in a way that more tillage is expected to have a lower soil health compared to the lesser tillage intensity. But in our case, it had a mixed effect. Living cover, for some reason, had a negative effect on the soil health indicators, and the rotation or the diversity did not play a major factor in these models. And then the management itself altogether explained about 20 to 50% of the variation in the soil health. So as you can see, management is only one of the factors combined together, one of the factors that affects the soil health indicators. The other factors that you may think of is the natural conditions, whether it is your soil condition or the weather or the long-term climate. So really, an important question to answer here is, does good soil health automatically mean good water quality? Okay. And really the contest here is we all are very much aware of the water quality issues that we're facing here in the state with the Western Lake Erie Basin facing more harmful algal blooms. The other bigger issue that has persisted over several decades is the Gulf of Mexico, the hypoxic zone that gets created in Gulf of Mexico, and then the major limiting nutrient there is, or nutrient of concern, is nitrate loss through the river systems. Here we're more worried about or the phosphorus, or the dissolved phosphorus is a nutrient of concern. So Will has recently published this first paper that really took all the edge of field data, soil data, and try to connect that with the edge of field water quality. These are all, this is the range of soil properties that was included. And then essentially what he tested was whether the fields with greater soil health tended to have reduced nitrogen and phosphorus losses in tile drainage and surface runoff. So that was really the objective here. Here is some results. So there is very consistent soil health and water quality relationship for fields with greater water extractable carbon. Again, another component of the organic matter. And nitrogen. So essentially, on the x-axis here, you see the water soluble organic matter or the carbon, and here what you see is a nitrate loss from tile drainage, and you can see in general, the greater the organic carbon, the greater the organic nitrogen losses. So that was part one. There was little evidence of a consistent relationship between other soil health indicators and water quality. So this is probably the only one that kind of highlighted in that study. Fields that had greater soil phosphorus had greater surface and tile phosphorus losses in general. So, so again, just to recap, the highlights from that study, I think I already mentioned this one. The greater nutrient concentrations that are favored by healthy soils are also cause greater risk of nutrient pollution. So that doesn't mean that a healthy soil is a concern. What we're suggesting here is what the data is showing is that there is potentially a need to look at the nutrient losses from healthy soils. Now, what are the direct effects of soil health practices on nitrogen and phosphorus losses? So this is kind of the second part of the question. I believe this was work done by Brittany Hanrahan, another researcher that works with the USDA group. And what you see here is all those edge of field sites, 40 fields divided into fields that had no cover crop during non-growing season versus fields that had cover crops. The top graph that you see is the nitrate loss, and the bottom graph is the total nitrogen loss. And you can see that cover crops play a major role, especially during non-growing season, to uptake a lot of the nitrogen from the field. So this was very obvious outcome from the data that cover crops actually do a really good job of keeping the nitrate losses lower. Okay. Now, so here is the conclusion of that study is almost 50% less nitrogen nitrate losses compared to the fields that had no cover. So that's very encouraging. However, the story of phosphorus losses was not very clear. There was no significant differences between the cover crop versus no cover crop fields with respect to phosphorus losses. They have explored similar topic using tillage as a treatment. So in general, tillage frequency has very little effect on the nitrate and dissolved phosphorus losses. Fields with more stratification of phosphorus had tended to have greater surface and tile phosphorus losses. So definitely tillage has a potential to reduce losses in these fields. And then that's the hypothesis that if you are able to redistribute that phosphorus in deeper layers, then there is potential for you to minimize the phosphorus losses. But how do you achieve that in a no-till system is still a bigger question. Again, some of the other research shows that minimizing the tillage significantly decreases the surface erosion and associated total phosphorus loss. So there are trade-offs between a system that is undisturbed versus a system that is continuously disturbed. In an undisturbed system like no-till systems, you're going to see this, the stratification of phosphorus in the top layer, and hence there is potentially greater risk of losing more phosphorus through the runoff. But the good side is if that field also helps reduce the surface runoff, then that risk is going to be minimized as well. So some of you are probably thinking, why is Vinayak giving you mixed messages here? And this is the nature of this this combination of soil health and water quality. It gets so complicated. It's almost a case by case basis analysis that you have to do. It's very difficult to be able to generalize the results. I am going to hand it over to Will. I believe he is on the Zoom call now, and I will continue to share my screen. But Will, are you able to take over from this point onwards?
Yep, I think so.
Okay.
Sorry, everyone. Had some technical difficulties. This is what happens when you become overconfident that you know how Zoom works. So even 3 years after we've come into the Zoom world, we're still learning. But yeah, I'll take over here. Vinayak, I'm guessing you covered up to this point, so I'll just keep pushing forward here. So yeah, this section here is talking about our edge of field results and some of the studies we've done looking at these specific soil health management practices. So for our diverse rotations, we don't actually have a lot of research specifically focused on looking at different crop rotations. We wish we had more, and we're working on that. But what we can tell you is there's been one study led by Lourdes Arueta, who is a graduate student at Ohio State. And she looked at comparing alfalfa in a rotation to an annual crop rotation. So comparing a perennial to an annual rotation. And she did find some pretty significant results for having that alfalfa. So she found that, looked at 2 different farms. At one of the farms, there were reductions in a number of different water quality parameters. So reduced discharge in the tile, reduced loads of nitrate, total nitrogen, and dissolved phosphorus. So a lot of effects at one farm. The second farm, she found only a significant effect of the alfalfa on total phosphorus losses. So a little more limited, but still an improvement in water quality at the second farm. So overall, Again, not a lot of information on rotation diversity yet, but we can say that having a perennial in the rotation does seem to improve water quality outcomes. Okay, you can pop to the next. Okay, manure, we do have more that we've done in the Edge of Field network. This is work led by Kevin King. There's a number of different studies I'm gonna touch on here. This first analysis, Kevin did across the entire Edge of Field network, looking at all the fields and basically just compared fields that had received manure applications. That would be the organic fields there in that bar. Compared those with either fields that had mixed applications, so both organic manure as well as inorganic fertilizer, and then compared that again to fields that had only received inorganic fertilizers. And overall, there was actually not a significant effect, a significant difference between the three fields, but you can see there's a clear trend there for greater phosphorus losses, and this is specifically looking at dissolved phosphorus losses from fields that had received that organic fertilizer. One important caveat with that study is Kevin didn't control for the underlying soil phosphorus levels. And we know in our network that the fields that tend to receive manure also tend to have greater soil phosphorus in those fields. So it's not entirely clear if this effect is due to the actual manure itself or due to that greater store of phosphorus in the field. Okay, a second study was more a direct one-to-one comparison of liquid dairy manure to MAP application. So these were done on 2 paired fields. And for this study, Kevin found some differences in both phosphorus and nitrate, but they were very minor. So not a big effect of the manure, but he did find the liquid dairy manure had slightly greater losses of dissolved phosphorus and nitrate through tile drains. Okay, and then the final study we've done here is, again, another paired field study, but this time instead of the dairy manure, it was poultry litter compared to commercial fertilizer. And for that study, Kevin found no differences whatsoever in the water quality coming off of those 2 fields. So overall, the effect of manure, not huge, but there is a little bit of evidence that using manure instead of commercial fertilizers might slightly increase our nutrient losses. And then another point here about manure applications, it's not just the immediate effect of manure that's going to be important. We have to also be thinking about the soil phosphorus levels. So like I mentioned in that first study, if we have fields where soil phosphorus levels are elevated, that's largely due to historic manure applications. And so obviously we can continue to have that effect on soil phosphorus if we're applying large amounts of manure over time, even today. So we've done, obviously some looking at how soil test phosphorus relates to phosphorus losses. And we know that it's a very important factor driving phosphorus losses. So we just pointing out that we have to keep soil test phosphorus in mind whenever we're considering applying manure applications to fields. Okay. All right, so a few conclusions from our ARS research. First, in terms of the soil health practices, unfortunately, I couldn't cover this myself, but I'm sure Vinayak did a fine job. We found basically that manure is the most effective practice out of those 4 different soil health practices. So more effective than cover crops, than diverse rotations or reduced tillage. There was a little bit of evidence that some of those other factors those management factors could have an effect on soil health, but manure is the big one we've been able to see so far. Second point here is we can't really assume that healthy soils are gonna lead to improved water quality outcomes. And I would argue that it's really the management practices themselves that are going to be more important. So yes, your management practices can affect soil health over time, but we haven't really been able to find any strong links between soil health and water quality improvements. But we need to keep in mind healthy soils have many other benefits. You know, we don't just want healthy soils for water quality. So clearly we still want to be pursuing healthy soils, soil health as one of our goals, but I don't think we can depend on that to help solve our nutrient loss issues. And then finally, this is sort of just a point for future research, but one of the big missing pieces in understanding what's driving our nutrient loss issues, our water quality issues, is actually the flow paths that water is using to get into the tile drains. And we think that macropores in the soil are playing a very large part of this story, especially in our more finely textured soils that we have up in the Lake Erie Basin. So that's one thing that our research unit is going to be working on moving forward, is trying to understand these macropores and how management, including soil health management, affects those flow paths through the soil. Okay. So that was all I was planning to cover, even though I only got the last little bit of it. So Vinayak, I think this would be your section to get into this sort of case study we've started working on the last couple of years.
Well, thank you, Will.
And I'll stick around for questions in case, you know, there's anything from that first half you guys want to hear more about from me, but I'll let Vinayak take it.
All right. Thank you, Will. If we do have some more time left in the end, I may have you go back to one of those soil health slides.
Okay.
But I might not have been able to do a good job. But let's look at that question that Will just mentioned. You know, soil health. There is a wide range of adoption for soil health. You will find some producers who are doing this for 50 years. You'll find some that are doing this for 15 years. You'll find some that are just into it a couple years. Especially with the H2 Ohio incentives that came through. You might have someone in the crowd that has not adopted this. So there is a range of maturity that you're looking at. So we decided to kind of join forces together and say, okay, well, let's explore this topic a little bit more in terms of what is the maturity level. How does that maturity level play a role in this whole equation of soil health as well as water quality? So this is a North Central Region SARE funded project that I am leading. Will and his team is very much part of it. It's a bigger team that we're working with. What you see here is two paired sites that have a unique pairing of treatments. There is a third site somewhere around here that is managed by the USDA group that is also going to be part of this research. But today I'm just going to show you results from these two sites. At each of these sites, what we're looking at is a field that has been under a very long-term soil health practice management. So for example, this field right here, it's just south of Columbus, has close to somewhere between 45 and 50 years into cover crops and no-till. We're comparing that with a adjacent field that is conventionally being managed in, and by which I mean no cover crops, a conventional tillage or a rotational tillage type of a system. Similar crop rotation, of course, cover crops, big part of this equation. This pair here, this field has somewhere between 25 to 30 years of the soil health practices versus a field that's being conventionally managed. We did try to select these fields that would have similar soil types, but of course we have a little more textural differences here in this pair compared to these two. And that becomes important, as Will mentioned. So part one of this project was to basically just do a soil health assessment over time and see how the soil health compares between those two fields that we're looking at, the long-term field versus a conventional. The unique thing about that field south of Columbus, we actually have a small portion of that field that is, we are calling that as a transitional field because it's not been under a long-term cover crop no-till system. So you might see some of those results as we go along. For the sake of time, we are not really presenting all the results from the soil health analysis because really the water quality is the focus. Organic matter tends to be a really good indicator of overall soil health, and this is the results from that south of Columbus site. Yellow is the conventional field, brown is the soil health field, and we had a grad student, Chris McNabb, go in and collect samples from the nearby woodlots, which are expected to be undisturbed soils during the periods when this was being farmed. Obviously, you would see a very high level of soil health indicators with the forest soil, but within that pair of conventional versus the soil health, the mature system, we did see a little bit of a greater trend with the healthy system versus the conventional. The interesting thing is we did not expect that other field to have such a high organic matter as well. So the other pair in Northwest Ohio had actually opposite trend, and we were scratching our heads trying to figure this out. But now we think that this other field has a little bit of a coarse soil texture compared to this field, and texture tends to play a bigger role in accumulation of organic matter. Just imagine if this field was in a conventional system, then this number would have probably looked much lower, and that's just an assumption at the moment. But that's Will, I don't know if you have anything to add here on top of that.
No, that's right. I think, you know, our long-term soil health field is sandier, and I'm sure any of the farmers in the audience would second that a sandier field, it tends to not hold on to its organic matter as effectively as a more silty type soil as we have in that conventional field.
And note that we did this for all the way up to 2 feet depth. So these are sample depths that I forgot to mention. All right, the second indicator was enzyme activity, and the enzyme activity that plays a role in carbon cycling versus nitrogen cycling. I'm gonna spend less time on this, but in general, you see that similar trend being followed, especially for the carbon cycling portion for that Southern Ohio site. For nitrogen cycling, you actually see a slightly reverse trend. Similar graph for the Northwest Ohio site. Will, anything to add here?
No, just that this is reflecting the patterns we see with the organic matter for the most part. So
yep. So it's very much driven by the organic matter. Physical properties, aggregate stability is a very good indicator of the physical property. It kind of shows you how resilient the soil may be for natural forces like the wind erosion or soil erosion. So what you want to see is these are different fraction sizes of aggregate. So a 2 millimeter aggregate is the largest that you can expect, 0.5 millimeter and 0.25. In a stable system or in a more mature system, you want to see more of this fraction, which you do see in general for those sites. Is you see a greater aggregation among those long-term sites. So that's a good reassurance that, okay, the aggregation is definitely working. Again, has a lot to do with the organic matter. I'm going to show you this right-hand side. We've talked a lot about organic matter, but this is not the exact same fields, but I had another study where around the same paired sites, we collected samples across a range of soil health history, and you do in general see greater biological activity in terms of the fungal as well as bacterial biomass as you go from a conventional to a transitional to a more mature system. Edge of field monitoring is very similar to what Will has presented earlier. Just want to take a moment here to recognize all the data that we present, how big a role our field monitoring crew plays here, as well as all of this work is possible with the cooperation that we get from our farmers and the funding that we get from different sources. So typically, I think very similar setup for these fields, paired fields, we would monitor a tile outlet and monitor surface runoff from both of these fields. We do have some visual indicators of how the water quality would look like between long-term soil health field. These photos were taken on the exact same day after a big event. And you can see the flume there that has so much sediment, and majority of this is a topsoil. But putting things in perspective in terms of numbers, what you see here is this is a tile drainage versus tile drainage loss and surface runoff loss, and DB is the long-term soil health field, and the MH is the conventional field. So what you see is a little bit of a more water leaving this field. So about 11 inches or so total water leaving this field, 13 inches or so of total water leaving. So a couple inches difference. The other paired site was in the Northwest Ohio, and here you see a good bit of a difference. In fact, we didn't measure any runoff from this field during the 2021 calendar year. Last year, we actually got at least a few events where we were able to measure some runoff. How that translates into nitrate losses and phosphorus losses is a question. I'm going to skip over this slide because I have a very good summary slide that puts things in perspective. So here is all those 40 fields that we were talking about for nitrate loss that they have observed as part of the edge of field network. The light bar is the subsurface drainage, and the dark is the surface runoff nitrate losses. And here is where our fields stand on that scale. So there, in general, there is already lower nitrate losses, but DB and DM are the fields that have long-term soil health, and they tend to have much less nitrate loss compared to the conventional fields. Dissolved phosphorus is a very unique story. You see very high concentration at one of our long-term soil health fields, and that was made us think. But when we looked at the total phosphorus losses, and I apologize for the small figure here, but really trying to show you where these 4 fields stand on the entire spectrum across Northwest Ohio's 40 fields. In general, we're still much below that 0.26 pounds of dissolved phosphorus loss per acre threshold that we're trying to set as a target for the Lake Erie Annex 4 reductions. But within that pair, the healthy fields, which is the DB and DM, tended to have much less phosphorus loss than the fields that were in conventional systems. So if you try to go back and remember what Will was presenting, this was not what he was presenting. There was slightly greater phosphorus losses from the fields that had more of a soil health management. So in general, I know this was too much to remember. We're seeing about, based on that 1 year of monitoring, we're seeing about 2 inches less water leaving a healthy soil field. about 12 pounds of less nitrogen leaving that healthy soil field, and about 0.05, so 500ths of a pound of dissolved phosphorus, less phosphorus leaving those healthy soil fields. Again, this is only 1 year of data, so we are calling this our preliminary data. We are working on the second year calendar year right now. We're hoping to publish these results through a master's thesis for a student, and then very soon with a paper. I just wanted to spend maybe just a couple more minutes before we open up for questions. We've been talking about soil health and water quality, and I started thinking, well, how about drainage and soil health as well? And of course, this has been a topic of interest. I was at National No-Till Conference, and there was a lot more talk about drainage than I had expected to see. So I thought maybe let's just take a look at what I can find just based on things that I've been involved with. Luckily, I didn't have to go too far. We actually had a long-term drainage, tillage, and crop rotation trial. Unfortunately, there was no cover crops involved. I wish there were cover crops involved, but maybe in future we can look into restarting this trial with a cover crop combination. The Northwest branch in Whiteville, many of you are familiar with, has had a set of research plots that were established in 1984, continued until 2009. And they had plow tillage, no-till, strip-till, zone builder as tillage practices. There was a continuous crop involved and a crop rotation, that is corn and soybean involved. And then the good news was this was done on drained plots as well as undrained plots. This is the results for corn yield in that combination. And this is a lot of data for you to even try to digest. Given the context with soil health, I'll probably just talk about the no-till as a context. Of course, you can consider strip-till as part of this equation. But if you look at drained plots under a rotation, which is more common in the Northwest Ohio to see as a combination, in a corn soybean rotation under drained conditions, you can see about 4% yield benefit to no-till compared to a conventional tillage. And this was based on this time period, 1984 through 2009 and 1992 to 2009. So it's not a 1 year of data. It's a very long-term research. So we can stand by these numbers comfortably. Even on an undrained land, and this may be a good context for maybe someone who is from central or southern Ohio, where you may or may not have drainage. Of course, you have very different soils. This was a Whiteville silty clay soil, but on a heavy textured soil, even in an undrained scenario, no-till actually helps get better yield response compared to a plow tillage. Not even talking about zone builder right now, but it kind of shined with the soybeans, which I think is not very common. So I'm not going to really spend time on zone builder, but again, comparing that no-till treatment with plow, you're looking at about 6% yield benefit over long term compared to a conventional tillage in a drained scenario. Well, that still plays a role even in an undrained scenario. Okay. All right. So we have the drainage and soil health equation. I started looking into this because I started seeing a lot of parallels between drainage and no-till. So I went back to the year that I was born in, 1982. One of my predecessors wrote a really nice fact sheet on 20 benefits of drainage. And I said, well, let's compare the benefits of drainage with benefits of soil health or no-till. So what you see is, let's start down here. Soil temperature, you know that if you have a drainage system, you tend to warm up soils in spring, probably faster than what undrained soil would do. Flip the coin. If you have a healthy soil with residue and no-till system and cover crops, that soil actually tends to stay a lot cooler in late summer, which is also something that you would want from water conservation's point of view. So kind of a really good working relationship between the two. Weed control is easier with drainage, was the reported benefit. Weed control is easier with cover crops in general in a healthy soil system. A lot of the research does focus on what is the benefit to crop yield, and if not to the crop yield, the profitability of the farm. And we pretty much have established a better profitability with both of these practices. One of the ways it actually helps you with your profitability, it actually takes the interannual yield variability out of the equation. So in the background that you see, that the shading that you see is a variability from drainage plots. If you have drainage, that much less yield variability from one year to another. Similar research has been shown with healthy soils or no-till systems. Both of these practices improve soil aeration, soil structure. But if you're going in and putting in new drainage in a system, then you expect to lose more organic matter because you're putting more oxygen into the soil profile. So that's going to decompose more organic matter in the beginning. But as soon as you start getting more yields, more biomass returning to that system, you may have a benefit of more organic matter build up, but you may or may not go back to that baseline where you started the first time you drained the soil. But over time, there is a potential for you to be able to build organic matter even in deeper depths if you have drainage. Soil health, it's no brainer. We know that it does build organic matter. Both of these tend to have been indicated to save fuel and provide trafficable conditions in the spring and fall. If you add water quality to the equation, so a lot of people forget that drainage primary benefit, water quality benefit drainage provides is reduce the surface runoff and hence reduce the risk of erosion. Same thing with no-till or cover crop systems. Soil erosion and sediment loss is the primary benefit that we get from these systems. Nitrate loss, as soon as you install drainage in an undrained soil, expect to see greater nitrate losses from the tile system. That is going to happen, and that has been the primary reason. You just change the hydrology of that field and the nitrate dissolves in the water and it finds a short circuit pathway. Well, a healthy soil can actually counteract to that. We just established that much less nitrate losses in a healthy soil. Phosphorus loss, on the other hand, is a very different story. As soon as you install drainage, you're reducing soil erosion, and hence from the surface pathways, you're reducing the total phosphorus loss from that soil. Here, similar result in terms of the particulate phosphorus losses through surface runoff. You're definitely looking at a reduction. But the most challenging factor that's affecting us right now is the story about dissolved phosphorus through subsurface drainage. This is where there is a lot of evidence that we have identified this pathway as a major pathway for phosphorus loss. Drainage, soil health may or may not play that role of completely controlling those phosphorus losses. And I hope this message is consistent. Will is seeing this slide first time, but I hope he agrees with what I'm saying here. One of the ways you can make this work really is both of these practices have a really great ability to pair up with other practices. This is where the opportunity is. This is where we can actually use these practices in a really good direction to enhance profitability, but also make them work for water quality if you have the option to pair them up with a practice that would then give you that enhanced benefit of water quality. Will, I'm going to let you give the closing remarks because I know that you haven't seen that slide, in case if you don't agree with any of that.
No, I think that's a nice little framework you laid out there, Vinayak, I guess the one maybe addition I would make is we probably shouldn't depend on soil health improvements themselves to give us any of these water quality benefits. But I think if we can consistently apply these practices, it's during the application of the practice or shortly after, like you plant a cover crop, for example, that's when you can see a benefit to water quality. It's maybe not the soil health improvements themselves that are doing it, but it's the practices that lead to soil health improvement also can help with the water quality. So a little bit of a nuance there, I guess, but
Absolutely. Yeah. Okay. Well, with that, I'm gonna thank you. I'm sorry we didn't leave you much time for Q&A, but happy to answer any questions there may be.
Thank you both very much for presenting for us today. Do we have some questions in the Q&A?
We do. And so the first question is, are there any correlations to pH or base saturations of calcium or magnesium to the soil health or water quality measurements?
I can take a stab at that. The short answer is no. We haven't looked at that yet. And this is something that I was recently at the Conservation Tillage Conference that I had a conversation about up there as well. So I know that's something that at least some of the producers are interested in, and it's something I'm gonna start looking at a little bit more. We do get those numbers when we send our soil samples to the labs, so it's definitely data we have and we can start looking at. But up to now, we haven't really delved into that particular question. So stay tuned, I guess. Hopefully we can have a better answer for that next time.
Thank you. So we also had a comment there in chat about it would be interesting to add strip till into the mix with conventional and no-till comparisons. Do either of you have anything to comment on that?
All I can say is I agree. Will?
Yeah, I mean, yes, it's always good to look at more practices. One of the challenges, obviously, with this sort of edge of field work is you're limited in the amount of fields you can look at, just because it takes a lot to actually monitor these fields year round for the water quality, which you really have to do to get the real picture of what the water quality impact is. So yes, I agree, strip till, and I know that's a popular practice. And one of the interesting things about strip till is it can maybe help us address our nutrient stratification issues without, fully doing away with the benefits of no-till. So maybe we can get a little bit of the best of both worlds with that strip till. So I do think that is a promising one. It would be really nice to do some work on that specifically.
All right. Well, thank you both. Do you have any other questions? If you could put those in the Q&A.